Question: what is a thought or reasoning chain in the context of a 0-1 model? What are LLMs and what are LRMs, and how do LRMs generate reasoning tokens that examine the problem, plan the structure of code, and generate multiple solutions before emitting the final answer? Magnifying glass tilted right. What is a thought or reasoning chain in the context of a 0-1 model? What are LLMs and what are LRMs, and how do LRMs generate reasoning tokens that examine the problem, plan the structure of code, and generate multiple solutions before emitting the final answer? A 0-1 model is a type of machine learning model that is designed to answer yes or no questions. It is based on the idea of a binary decision tree, where each internal node represents a decision based on a feature, and each leaf node represents a class label. LLMs, language learning models, are a type of machine learning model that are designed to learn and understand natural language. They are typically trained on large datasets of text, and are able to generate human-like text based on a given prompt. LRMs, logical reasoning models, are a type of machine learning model that are designed to perform logical reasoning tasks. They are typically trained on large datasets of logical reasoning problems, and are able to generate solutions to new problems based on the patterns and rules they have learned. In the context of a 0-1 model, an LLM can be used to generate reasoning tokens that examine the problem and generate a plan for solving it. The LRMs can then use these reasoning tokens to generate multiple solutions to the problem, and then select the best one based on a set of criteria. For example, if the problem is what is the square root of 16, the LLM might generate reasoning tokens such as start by identifying the number whose square is the given number and perform the calculation to find the square root. The LRMs can then use these tokens to generate solutions such as the square root of 16 is 4 and the square root of 16 is -4, and then select the correct answer based on the fact that the square root of a number is always positive. In summary, LLMs and LRMs are two types of machine learning models that can be used in conjunction with a 0-1 model to generate reasoning tokens and multiple solutions to a problem, and then select the best one. Stethoscope magnifying glass tilted left. Search results February 28, 2024. How to think step by step, a mechanistic understanding of chain of thought reasoning. Down arrow, Subabrata Dutta, Joykarat Singh, Somen Chakrabarti, Tanmoy Chakraborty. Despite superior reasoning prowess demonstrated by large language models, LLMs, with chain of thought, CAT, prompting, a lack of understanding prevails around the internal mechanisms of the models that facilitate CAT generation. This work investigates the neural substructures within LLMs that manifest CAT reasoning from a mechanistic point of view. From an analysis of Llama 2.7b applied to multi-step reasoning over fictional ontologies, we demonstrate that LLMs deploy multiple parallel pathways of answer generation for step-by-step reasoning. These parallel pathways provide sequential answers from the input question context as well as the generated CAT. We observe a striking functional rift in the middle layers of the LLM. Token representations in the initial half remain strongly biased towards the pre-training prior, with the in-context taking over abruptly in the later half. This internal phase shift manifests in different functional components. Attention heads that write the answer token predominantly appear in the later half. Attention heads that move information along ontological relationships appear exclusively in the initial half, and so on. To the best of our knowledge, this is the first attempt towards mechanistic investigation of CAT reasoning in LLMs. June 12, 2023. Recursion of thought, a divide-and-conquer approach to multi-context reasoning with language models. Down arrow, Suchan Lee and Gun-hee Kim. Generating intermediate steps, or chain of thought, CAT, is an effective way to significantly improve language models, LM, multi-step reasoning capability. However, the CAT lengths can grow rapidly with the problem complexity, easily exceeding the maximum context size. Instead of increasing the context limit, which has already been heavily investigated, we explore an orthogonal direction, making LMs divide a problem into multiple contexts. We propose a new inference framework, called recursion of thought, ROT, which introduces several special tokens that the models can output to trigger context-related operations. Extensive experiments with multiple architectures, including GPT-3, show that ROT dramatically improves LM's inference capability to solve problems, whose solution consists of hundreds of thousands of tokens. July 20, 2023, Boosting Language Models Reasoning with Chain of Knowledge Prompting, down arrow, Jianing Wang, Xiaoshi Sun, Nuo Chen, Xiangli, Mingyao. Recently, Chain of Thought, CAT, prompting has delivered success on complex reasoning tasks, which aims at designing a simple prompt like "let's think step by step" or multiple in-context exemplars with well-designed rationales to elicit large language models, LLMs, to generate intermediate reasoning steps. However, the generated rationales often come with mistakes, making unfactual and unfaithful reasoning chains. To mitigate this brittleness, we propose a novel chain of knowledge, COK, prompting, where we aim at eliciting LLMs to generate explicit pieces of knowledge evidence in the form of structure triple. This is inspired by our human behaviors, i.e., we can draw a mind map or knowledge map as the reasoning evidence in the brain before answering a complex question. Benefiting from COK, we additionally introduce AF-2 verification method to estimate the reliability of the reasoning chains in terms of factuality and faithfulness. For the unreliable response, the wrong evidence can be indicated to prompt the LLM to rethink. Extensive experiments demonstrate that our method can further improve the performance of common sense, factual, symbolic, and arithmetic reasoning tasks. November 16, 2023, Graph-Guided Reasoning for Multi-Hop Question Answering in Large Language Models, down arrow, Jin-Young Park, Amin Patel, Omar Zia Khan, Hyunwoo Jae, Kim, Jukyung Kim. Chain of Thought, CAT, prompting has boosted the multi-step reasoning capabilities of large language models, LLMs, by generating a series of rationales before the final answer. We analyze the reasoning paths generated by CAT and find two issues in multi-step reasoning: I, generating rationales irrelevant to the question; 2, unable to compose sub-questions or queries for generating/retrieving all the relevant information. To address them, we propose a graph-guided CAT prompting method, which guides the LLMs to reach the correct answer with graph representation/verification steps. Specifically, we first leverage LLMs to construct a question/rationale graph by using knowledge extraction prompting given the initial question and the rationales generated in the previous steps. Then, the graph verification step diagnoses the current rationale triplet by comparing it with the existing question/rationale graph to filter out irrelevant rationales and generate follow-up questions to obtain relevant information. Additionally, we generate CAT paths that exclude the extracted graph information to represent the context information missed from the graph extraction. Our graph-guided reasoning method shows superior performance compared to previous CAT prompting and the variance on multi-hop question answering benchmark datasets. January 19, 2024, Chain of Table, Evolving Tables in the Reasoning Chain for Table Understanding, down arrow, Zilong Wang, Hao Zhang, Chunliang Li, Julian Martin Eisenschloss, Vincent Perot, Zifeng Wang, Leslie Mikulasik, Yasuhisa Fuji, Jingbo Sheng, Chenyu Li. Tomas Pfister. Table-based reasoning with large language models, LLMs, is a promising direction to tackle many table understanding tasks, such as table-based question answering and fact verification. Compared with generic reasoning, table-based reasoning requires the extraction of underlying semantics from both free-form questions and semi-structured tabular data. Chain of Thought and its similar approaches incorporate the reasoning chain in the form of textual context, but it is still an open question how to effectively leverage tabular data in the reasoning chain. We propose the chain of table framework, where tabular data is explicitly used in the reasoning chain as a proxy for intermediate thoughts. Specifically, we guide LLMs using in-context learning to iteratively generate operations and update the table to represent a tabular reasoning chain. LLMs can therefore dynamically plan the next operation based on the results of the previous ones. This continuous evolution of the table forms a chain, showing the reasoning process for a given tabular problem. The chain carries structured information of the intermediate results, enabling more accurate and reliable predictions. Chain of Table achieves new state-of-the-art performance on WikiTQ, FetaQA, and TabFact benchmarks across multiple LLM choices. March 2, 2023, Language Models Are Greedy Reasoners, a systematic formal analysis of chain of thought, down arrow, Abelhar-Saparov and Hihi. Large language models, LLMs, have shown remarkable reasoning capabilities given chain of thought prompts, examples with intermediate reasoning steps. Existing benchmarks measure reasoning ability indirectly by evaluating accuracy on downstream tasks such as mathematical reasoning. However, it is unclear how these models obtain the answers and whether they rely on simple heuristics rather than the generated chain of thought. To enable systematic exploration of the reasoning ability of LLMs, we present a new synthetic question-answering dataset called PR-onto-QA, where each example is generated from a synthetic world model represented in first-order logic. This allows us to parse the generated chain of thought into symbolic proofs for formal analysis. Our analysis on InstructGPT and GPT-3 shows that LLMs are quite capable of making correct individual deduction steps, and so are generally capable of reasoning, even in fictional contexts. However, they have difficulty with proof planning. When multiple valid deduction steps are available, they are not able to systematically explore the different options. September 28, 2023, TPE, Towards Better Compositional Reasoning Over Conceptual Tools with Multi-Persona Collaboration, down arrow, Hongru Wang, Weimin Wang, Lingji Wang, Minda Hu, Rui Wang, Woyang Shui, Hongyuan Liu, Fei Mi, CAM-FAI Wang. Large language models, LLMs, have demonstrated exceptional performance in planning the use of various functional tools, such as calculators and retrievers, particularly in question-answering tasks. In this paper, we expand the definition of these tools, centering on conceptual tools within the context of dialogue systems. A conceptual tool specifies a cognitive concept that aids systematic or investigative thought. These conceptual tools play important roles in practice, such as multiple psychological or tutoring strategies being dynamically applied in a single turn to compose helpful responses. To further enhance the reasoning and planning capability of LLMs with these conceptual tools, we introduce a multi-persona collaboration framework, Think Plan Execute, TPE. This framework decouples the response generation process into three distinct roles: thinker, planner, and executor. Specifically, the thinker analyzes the internal status exhibited in the dialogue context, such as user emotions and preferences, to formulate a global guideline. The planner then generates executable plans to call different conceptual tools, e.g., sources or strategies, while the executor compiles all intermediate results into a coherent response. This structured approach not only enhances the explainability and controllability of responses but also reduces token redundancy. We demonstrate the effectiveness of TPE across various dialogue response generation tasks, including multi-source, focus, and multi-strategy interactions, schema and PsyQA. This reveals its potential to handle real-world dialogue interactions that require more complicated tool learning beyond just functional tools. The full code and data will be released for reproduction. October 19, 2023, Large Language Models Are Better Reasoners with Self-Verification, down arrow, Ishuan Wang, Minjun Zhu, Fei Xia, Binli, Shizhu He, Shangping Liu, Bin Sun, Kung Liu, Jun Zhao. Recently, with the chain of thought, CAT, prompting, large language models, LLMs, e.g., GPT-3, have shown strong reasoning ability in several natural language processing tasks such as arithmetic, common sense, and logical reasoning. However, LLMs with CAT require multi-step prompting and multi-token prediction, which is highly sensitive to individual mistakes and vulnerable to error accumulation. The above issues make the LLMs need the ability to verify the answers. In fact, after inferring conclusions in some thinking decision tasks, people often check them by re-verifying steps to avoid some mistakes. In this paper, we propose and prove that LLMs also have similar self-verification abilities. We take the conclusion obtained by CAT as one of the conditions for solving the original problem. By performing a backward verification of the answers that LLM deduced for itself, we can obtain interpretable answer validation scores to select the candidate answer with the highest score. Experimental results demonstrate that the proposed method can improve the reasoning performance on various arithmetic, common sense, and logical reasoning datasets. Our code is publicly available at https://github.com/wangsuc/self-verification. November 7, 2023, Leveraging Structured Information for Explainable Multi-Hop Question Answering and Reasoning, down arrow, recently, Shinyadu neural models, including large language models, LLMs, achieve superior performance on multi-hop question answering. To elicit reasoning capabilities from LLMs, recent works propose using the chain of thought, CAT, mechanism to generate both the reasoning chain and the answer, which enhances the model's capabilities in conducting multi-hop reasoning. However, several challenges still remain, such as struggling with inaccurate reasoning, hallucinations, and lack of interpretability. On the other hand, information extraction, i.e., identifies entities, relations, and events grounded to the text. The extracted structured information can be easily interpreted by humans and machines, Grishman, 2019. In this work, we investigate constructing and leveraging extracted semantic structures, graphs, for multi-hop question answering, especially the reasoning process. Empirical results and human evaluations show that our framework generates more faithful reasoning chains and substantially improves the QA performance on 2 benchmark datasets. Moreover, the extracted structures themselves naturally provide grounded explanations that are preferred by humans, as compared to the generated reasoning chains and saliency-based explanations. February 25, 2024, Towards a Unified View of Answer Calibration for Multi-Step Reasoning, down arrow, Shumin Deng, Ningyu Zhang, Neu, Brian Hui. Large Language Models, LLMs, employing chain of thought, CAT, prompting have broadened the scope for improving multi-step reasoning capabilities. We generally divide multi-step reasoning into 2 phases, path generation to generate the reasoning paths, and answer calibration post-processing the reasoning paths to obtain a final answer. However, the existing literature lacks systematic analysis on different answer calibration approaches. In this paper, we summarize the taxonomy of recent answer calibration techniques and break them down into step-level and path-level strategies. We then conduct a thorough evaluation on these strategies from a unified view, systematically scrutinizing step-level and path-level answer calibration across multiple paths. Experimental results reveal that integrating the dominance of both strategies tends to derive optimal outcomes. Our study holds the potential to illuminate key insights for optimizing multi-step reasoning with answer calibration. September 20, 2023, Faithful Chain of Thought Reasoning, down arrow, Qing Liu, Shreya Havalder, Adam Stein, Li Zheng, Dilip Rao, Eric Wang, Mariana Apidianaki, Chris Callison-Birch. While Chain of Thought, CAT, prompting boosts language models, LM, performance on a gamut of complex reasoning tasks, the generated reasoning chain does not necessarily reflect how the model arrives at the answer, aka faithfulness. We propose Faithful CAT, a reasoning framework involving 2 stages, translation, natural language query $writer symbolic reasoning chain, and problem solving, reasoning chain $writer answer, using an LM and a deterministic solver, respectively. This guarantees that the reasoning chain provides a faithful explanation of the final answer. Aside from interpretability, Faithful CAT also improves empirical performance. It outperforms standard CAT on 9 of 10 benchmarks from 4 diverse domains, with a relative accuracy gain of 6.3% on math word problems, MWP 3.4% on planning, 5.5% on multi-hop question answering, QA, and 21.4% on relational inference. Furthermore, with GPT-4 and Codex, it sets the new state-of-the-art few-shot performance on 7 datasets, with 95.0+ accuracy on 6 of them, showing a strong synergy between faithfulness and accuracy. February 16, 2024, can we verify step-by-step for incorrect answer detection? Down arrow, Xian Su, Shizhe Diao, Ken Yang, Yang Wang. Chain of Thought, CAT, prompting has marked a significant advancement in enhancing the reasoning capabilities of large language models, LLMs. Previous studies have developed various extensions of COT, which focus primarily on enhancing end-task performance. In addition, there has been research on assessing the quality of reasoning chains in COT. This raises an intriguing question: is it possible to predict the accuracy of LLM outputs by scrutinizing the reasoning chains they generate? To answer this research question, we introduce a benchmark, R2PE, designed specifically to explore the relationship between reasoning chains and performance in various reasoning tasks spanning 5 different domains. This benchmark aims to measure the falsehood of the final output of LLMs based on the reasoning steps. To make full use of information in multiple reasoning chains, we propose the Process Discernibility Score, PDS, framework that beats the answer-checking baseline by a large margin. Concretely, this resulted in an average of 5.1% increase in the F1 score across all 45 subsets within R2PE. We further demonstrate our PDS's efficacy in advancing open domain QA accuracy. Data and code are available at https://github.com/xanxu-ustc/R2PE. October 7, 2022, Automatic Chain of Thought Prompting in Large Language Models, Down Arrow, Zhuoxing Zheng, Aston Zhang, Mu Li, Alex Smala. Large language models, LLMs, can perform complex reasoning by generating intermediate reasoning steps. Providing these steps for prompting demonstrations is called chain of thought, CAT, prompting. CAT prompting has 2 major paradigms. One leverages a simple prompt like "let's think step by step" to facilitate step-by-step thinking before answering a question. The other uses a few manual demonstrations one by one, each composed of a question and a reasoning chain that leads to an answer. The superior performance of the second paradigm hinges on the handcrafting of task-specific demonstrations one by one. We show that such manual efforts may be eliminated by leveraging LLMs with the "let's think step-by-step" prompt to generate reasoning chains for demonstrations one by one, i.e., let's think not just step by step, but also one by one. However, these generated chains often come with mistakes. To mitigate the effect of such mistakes, we find that diversity matters for automatically constructing demonstrations. We propose an automatic COT prompting method, AutoCOT. It samples questions with diversity and generates reasoning chains to construct demonstrations. On 10 public benchmark reasoning tasks with GPT-3, AutoCOT consistently matches or exceeds the performance of the COT paradigm that requires manual designs of demonstrations. Code is available at https://github.com/amazon-research/auto-cot. February 25, 2024. Code prompting elicits conditional reasoning abilities in text plus code LLMs. Down Arrow, Haritz Porta, Martin Tutek, Somukhadifir, Xiaodan Zhu. Arena Gurevich reasoning is a fundamental component of language understanding. Recent prompting techniques, such as chain of thought, have consistently improved LLM's performance on various reasoning tasks. Nevertheless, there is still little understanding of what triggers reasoning abilities in LLMs in the inference stage. In this paper, we introduce code prompting, a chain of prompts that transforms a natural language problem into code and directly prompts the LLM using the generated code without resorting to external code execution. We hypothesize that code prompts can elicit certain reasoning capabilities of LLMs trained on text and code and utilize the proposed method to improve conditional reasoning, the ability to infer different conclusions depending on the fulfillment of certain conditions. We find that code prompting exhibits a high performance boost for multiple LLMs, up to 22.52 percentage points on GPT 3.5, 7.75 on Mixtral, and 16.78 on Mistral, across multiple conditional reasoning datasets. We then conduct comprehensive experiments to understand how code prompts trigger reasoning abilities and which capabilities are elicited in the underlying models. Our analysis of GPT 3.5 reveals that the code formatting of the input problem is essential for performance improvement. Furthermore, Code prompts improve sample efficiency of in-context learning and facilitate state tracking of variables or entities. December 3, 2023, Tree of Thoughts, Deliberate Problem Solving with Large Language Models, Down Arrow, Xuanyu Yao, Dian Yu, Jeffrey Zhao, Azak Shafran, Thomas L. Griffiths, Yuan Chao. Karthik Narasimhan language models are increasingly being deployed for general problem solving across a wide range of tasks, but are still confined to token-level, left-to-right decision-making processes during inference. This means they can fall short in tasks that require exploration, strategic look ahead, or where initial decisions play a pivotal role. To surmount these challenges, we introduce a new framework for language model inference, Tree of Thoughts, TOT, which generalizes over the popular chain of thought approach to prompting language models, and enables exploration over coherent units of text, thoughts, that serve as intermediate steps toward problem solving. TOT allows LMs to perform deliberate decision-making by considering multiple different reasoning paths and self-evaluating choices to decide the next course of action, as well as looking ahead or backtracking when necessary to make global choices. Our experiments show that TOT significantly enhances language models' problem-solving abilities on 3 novel tasks requiring non-trivial planning or search, Game of 24, creative writing, and mini crosswords. For instance, in Game of 24, while GPT-4 with chain of thought prompting only solved 4% of tasks, our method achieved a success rate of 74%. Code repo with all prompts. https://github.com/princeton-nlp/tree-of-thought-LLM. February 27, 2024, Small language models fine-tuned to coordinate larger language models improve complex reasoning, Down Arrow, Gurusha Juneja, Subabrata Dutta, Somen Chakrabarty, Sunny Manchanda, Tanmoy Chakraborty. Large language models, LLMs, prompted to generate chain of thought, CUT, exhibit impressive reasoning capabilities. Recent attempts at prompt decomposition towards solving complex, multi-step reasoning problems depend on the ability of the LLM to simultaneously decompose and solve the problem. A significant disadvantage is that foundational LLMs are typically not available for fine-tuning, making adaptation computationally prohibitive. We believe and demonstrate that problem decomposition and solution generation are distinct capabilities, better addressed in separate modules than by one monolithic LLM. We introduced LLM, which uses a decomposition generator to decompose complex problems into subproblems that require fewer reasoning steps. These subproblems are answered by a solver. We use a relatively small, 13B parameters, LM as the decomposition generator, which we train using policy gradient optimization to interact with a solver LM, regarded as black box, and guide it through subproblems, thereby rendering our method solver agnostic. Evaluation on multiple different reasoning datasets reveal that with our method, a 175 billion parameter LM, Text DaVinci 003, can produce competitive or even better performance, compared to its orders of magnitude larger successor, GPT-4. Additionally, we show that LLM is not limited by the solver's capabilities as a function of scale, e.g., solver LMs with diverse sizes give significant performance improvement with our solver-agnostic decomposition technique. Exhaustive ablation studies evince the superiority of our modular fine-tuning technique over exorbitantly large decomposer LLMs, based on prompting alone. March 10, 2023, React, Synergizing Reasoning and Acting in Language Models, Down Arrow, Xuanyu Yao, Jeffrey Zhao, Dian Yu, Nandu, Vizak Shafran, Karthik Narasimhan, Yuan Chao. While large language models, LLMs, have demonstrated impressive capabilities across tasks in language understanding and interactive decision-making, their abilities for reasoning, e.g. chain of thought prompting, and acting, e.g. action plan generation, have primarily been studied as separate topics. In this paper, we explore the use of LLMs to generate both reasoning traces and task-specific actions in an interleaved manner, allowing for greater synergy between the two. Reasoning traces help the model induce, track, and update action plans as well as handle exceptions, while actions allow it to interface with external sources, such as knowledge bases or environments, to gather additional information. We apply our approach, named REACT, to a diverse set of language and decision-making tasks and demonstrate its effectiveness over state-of-the-art baselines, as well as improved human interpretability and trustworthiness over methods without reasoning or acting components. Concretely, on question answering, hotpot QA, and fact verification, fever, REACT overcomes issues of hallucination and error propagation prevalent in chain-of-thought reasoning by interacting with a simple Wikipedia API, and generates human-like task-solving trajectories that are more interpretable than baselines without reasoning traces. On two interactive decision-making benchmarks, ALF World and WebShop, REACT outperforms imitation and reinforcement learning methods by an absolute success rate of 34% and 10% respectively, while being prompted with only one or two in-context examples. Project site with code, https://react-lm.github.io December 5, 2023, Unleashing the Creative Mind. Language model as hierarchical policy for improved exploration on challenging problem solving. Down arrow, Zhang Ling, Yunhao Feng, Xianlin Li, Tongzhou Mu, Minggu Li, Reza Poreza, Roland Memisevic, Haosu. Large language models, LLMs, have achieved tremendous progress, yet they still often struggle with challenging reasoning problems. Current approaches address this challenge by sampling or searching detailed and low-level reasoning chains. However, these methods are still limited in their exploration capabilities, making it challenging for correct solutions to stand out in the huge solution space. In this work, we unleash LLM's creative potential for exploring multiple diverse problem-solving strategies by framing an LLM as a hierarchical policy via in-context learning. This policy comprises of a visionary leader that proposes multiple diverse high-level problem-solving tactics as hints, accompanied by a follower that executes detailed problem-solving processes following each of the high-level instruction. The follower uses each of the leader's directives as a guide and samples multiple reasoning chains to tackle the problem, generating a solution group for each leader proposal. Additionally, we propose an effective and efficient tournament-based approach to select among these explored solution groups to reach the final answer. Our approach produces meaningful and inspiring hints, enhances problem-solving strategy exploration, and improves the final answer accuracy on challenging problems in the math dataset. Code will be released at https://github.com/lz1oceani/llm-as-hierarchical-policy. December 7, 2023, Latent Skill Discovery for Chain-of-Thought Reasoning, Down arrow, Zifan Su, Haozhu Wang, Dmitry Bespalov, Peter Stone, Yanjun Qi. Recent advances in large language models, LLMs, have led to an emergent ability of chain-of-thought, CUT, prompting, a prompt reasoning strategy that adds intermediate rationale steps between questions and answers to construct prompts. Conditioned on these prompts, LLMs can effectively learn in context to generate rationales that lead to more accurate answers than when answering the same question directly. To design LLM prompts, one important setting, called demonstration selection, considers selecting demonstrations from an example bank. Existing methods use various heuristics for this selection, but for CUT prompting, which involves unique rationales, it is essential to base the selection upon the intrinsic skills that CUT rationales need, for instance, the skills of addition or subtraction for math word problems. To address this requirement, we introduce a novel approach named Reasoning Skill Discovery, RSD, that use unsupervised learning to create a latent space representation of rationales, called a reasoning skill. Simultaneously, RSD learns a reasoning policy to determine the required reasoning skill for a given question. This can then guide the selection of examples that demonstrate the required reasoning skills. Our approach offers several desirable properties. It is 1. Theoretically grounded, 2. Sample efficient, requiring no LLM inference or manual prompt design, and 3. LLM agnostic. Empirically, RSD outperforms existing methods by up to 6% in terms of the answer accuracy across multiple reasoning tasks. May 26, 2023, Plan and Solve Prompting, Improving Zero-Shot Chain-of-Thought Reasoning by Large Language Models, Down arrow, Lei Wang, Wanyu Su, Ey Lan, Jiqiang Hu, Yunxia Lan, Roy-Ka-wei Li and Yipeng Lim large language models, LLMs, have recently been shown to deliver impressive performance in various NLP tasks. To tackle multi-step reasoning tasks, few-shot chain of thought, CUT, prompting includes a few manually crafted step-by-step reasoning demonstrations which enable LLMs to explicitly generate reasoning steps and improve their reasoning task accuracy. To eliminate the manual effort, Zero-Shot CUT concatenates the target problem statement with "let's think step-by-step" as an input prompt to LLMs. Despite the success of Zero-Shot CUT, it still suffers from 3 pitfalls: calculation errors, missing step errors, and semantic misunderstanding errors. To address the missing step errors, we propose Plan and Solve (PS) prompting. It consists of 2 components. First, devising a plan to divide the entire task into smaller subtasks, and then carrying out the subtasks according to the plan. To address the calculation errors and improve the quality of generated reasoning steps, we extend PS prompting with more detailed instructions and derive PS plus prompting. We evaluate our proposed prompting strategy on 10 datasets across 3 reasoning problems. The experimental results over GPT-3 show that our proposed zero-shot prompting consistently outperforms Zero-Shot CUT across all datasets by a large margin, is comparable to or exceeds Zero-Shot Program of Thought prompting, and has comparable performance with 8-shot CUT prompting on the math reasoning problem. The code can be found at https://github.com/agi-edgerunners/plan-and-solve-prompting.